Hello, I'm audible, huh? Mm, So I think we should wait for 5 more minutes. Let's people join. So do people have any doubt regarding sessions? Means the three lectures mostly. You can ask one by one if you have any. So three people only join. So do you have any doubt? You can ask right now. All of three were joined. I will start with the problems directly that I have discovered. I'm audible or not? Because no one is answering anything. Hello? So everything is working fine.
Please start.
So nobody have any problem. Three people are joining it. Okay. We will start at Wi-Fi. So we start with our first problem solving and doubt clearing session. I'm asking again if anybody having any doubt, you can ask right now. That from the lecture series that we have shown, seen from week. So, so okay. So if nobody has any doubt, we can start with the problems. I'm audible to everyone. Just speak. Come on, because it is only I think three people are joined and we need to give answers to the questions. So we start here with here. So about this is the first problem solving session and after session for ME91 Production Technology Theory and Practices. I am Garg Saurabh, PMR scholar of IIT Madras, working in manufacturing department of mechanical department. So we start with our first problem. That is, so that this is the first problem. So anybody knows the answer? Percentage of carbon in medium carbon steel. Basically, this is about problem solving session. So if you have any doubt or the kind of question that can be asked in exam that we are able to solve. So it is mostly for why you're not opening your mic then? Because yeah, the correct answer is B only. Yeah, it's B. What about other two peoples? They are here or not? That is even
Yeah, it's B.
yeah, it's okay. So this is the second question. What is B you know about the percentage of carbon and medium carbon steel that is less than 3 is for different. So it is given every in that slide itself at what amount of medium carbon steel it is. So again, this nickel is added in the steel to improve. This is mostly a problem solving session for you. That is what kind of problems can be asked in assignments and any doubt that you have is about that only. This similar kind of question might be asked in exams and in assignments also. So our more our main motive is to you should get learn. So if mostly you are here to answer your strength and hardness, you need to see the actual answer is strength and toughness, not hardness. This is the tricky part. You need to be very particular about your answers. Toughness is more important. This can be added using nickel. It is given in the chat. As it is a theory subject, you need to be focused on what kind of theory they are actually properties things are given in it. So you need to be focused on the theory part. Problems part are there, but these kind of theory part that what can be added, these things are fixed. These are done by research. So you need to keep things in the mind. There are many few amount of materials that can be added. So you must keep in your mind that what kind of things this material should give. They are different, like chromium is there, molybdenum is there, vanadium is there. They have specific properties when they enter into their atomic structure, where those molecular structure, the spheres that we have, it changes their distances and the planes and slips. So it creates that kind of particular microstructure to support for the specific amount of it is there. You can see this, the content that I'm showing here is only from the slides, not anything outside of the slides. You can see it is in the slide. It is given the strength and hard toughness. This is depend upon the property. That is, we can't change it. It is done through research. Why you can't ask why it is not toughness? It is because of the change in microstructure. It is in nickel tends to do that for more specific why we need to go through that microstructure and how it is working on it. So for this course we are not going up to that much level, but for different materials that properties are different, and according to the properties the microstructure is changing and we are getting those things. So asking why you need to go through the research domain mostly.
Now, my question was
Hmm?
that you see, strength and hardness it increases.
Hmm?
Okay, but strength and toughness, why not strength and hardness also? Both the options are there. That is what was I'm saying. It
No,
can
but
be both the choices.
no, it is strictly according to the slides. We are not doing anything about
Fine, I agree. That is
uh,
okay. Okay,
uh,
but then
uh,
I'm asking for a reasoning. Like, okay, when you go over the hardness numbers, if you add nickel, it goes up. Okay, what about toughness? Suppose I've got two options which are nearer. I agree that it is there, but then why? That is the question. That what is the
what
logic behind it?
So what is your background actually?
I am a production engineer, and I am into valuations. I have my own company. My purpose of this course is to just brush up the this thing. I've worked in steel plants and I've worked in this thing, so just wanted to know this. At times, what happens is that here a lot of these multiple choice questions, there are two or three options that are correct. That
Yes,
was the
yes.
only purpose of asking. That was the only purpose of asking you.
No, why hardness is not there? You need to remember those things because we need to go up to that level in research. At why it is not hardness. Why I think hardness is not given by nickel. For hardness, it is scratch resistant materials. So mostly martensite and those kind of areas. When you see about martensitic areas, it is scratch resistant. It is not able to scratch. But toughness is different property. Hardness is different property. So for hardness, I think so. You need to add different materials. Depending upon mostly hardness, when hardness will go, what is the meaning? It is scratch mostly happens. Mostly when we add
Yeah.
different more. Mostly when we are intentionally adding for strains, then means any big atoms. If you are adding for but more than the substitution or the whites it has mostly. If you see through slides, I think so. It's that only. So I think you have to go deeper. I think in next session I will tell you. Right now I also don't know.
Is
But
there any measurement of toughness like hardness? There is Brinell's hardness number.
toughness are there now. You can measure it is in slides. It is given. I think so. How it is done. Measure of toughness, it is, I think so, it is in the stress strain curve, it is find it. Mostly it is RP test, I think so, for toughness. It is impact test, actually. You can get toughness by impact tests. How much energy it can store, you can get by that. The RP and ISO test are there, both tests you can do. For specifically for nickel, this property that we need to go further research at how the things are working beside behind it. Okay, so we go with next. I will answer a question next session. This is the major alloying element in stainless steel. Yeah, it's right. Chromium, mostly it is chromium. It is 11%. I think we are adding as a major alloying element in stainless steel. It is actually used for as a corrosion resistance. It forms an oxide layer, and due to which it can be act as a corrosion resistance also. It is called as stainless steel because mainly it should not be corroded. So again, this is the property must be taken in. Yeah, chromium is correct. So fourth question now. Yeah, shock and wear resistance because it is tool. Yeah, it's correct because it is a tool. Mostly in case of tool, it is mostly shock and it should be wear resistant because it need to scratch. Again, the hardness part will come into the picture. It need to scratch the material to tear the material. So all the others are not close to that even. It is shock resistance is the correct answer. Okay, so percentage of silicon. Question 5. So let me rewrite me. So carbide tips enhance that. Yeah, mostly shock resistor is built by carbides only. It is in lecture series, it is given that why carbide is given. So it's a property that for mostly it is used in case of only because it's property that it depends upon how much material, how much production we are using. So how much cost we are using and what amount of product we are getting. We are mostly working for optimal conditions. So for optimal conditions, we need to check what the best property should be. So wear resistance and shock is a very important for tool. Other strength and other things we not consider. So the base property which we have, we only consider that. Rest of the properties can be taken care by other factors. So we don't much focus on that because our main option is to optimal means at maximum efficiency we should have. We should maximum efficiency and minimum cost. So our energy should be less and our product must be maximum. So that's how we should work and for that specific things we are working on. For specific properties, we will think that how our production should be maximized. That is only the fact that production engineer, manufacturing engineer should do with amount of resources that we have in our company or in our shop floor. So specific properties are given for specific tools, like in cases of tourist tools, to get benefit for that specific operations. That's only the case. But it is the shock and wear resistance that we are using. So again, the percentage of silicon added in the steel for enhancing the electrical. Yeah, see, it's correct. This is mostly this kind of in manufacturing, mostly this kind of problems will be asked because it is mostly memory based, that I know, but this is the small tricks that you should understand because it is material science again. So in material science, there is most of the research must be done. So it is research has been done already. So these kind of tricks are available. So you have to go through that domain only to, as increase our production mostly when we think on that areas. Yeah, you can search now even, but depend. But this kind of problem will become here mostly exams, and mostly here we have to learn. So how the exams will become, that is again a different part. But what is your understanding from the questions that or the week, the lectures you have gone through, that is more important. So it is more important about your learning. So that is the case. So you can even ask doubt, that is for that if you want. This is again C is
Where
the
is this
graph.
kind of steel used with high silicon content, with
Where it is,
electrical and magnetic properties? Is it in hatch, in marine industry hatch, where they have got magnetic and electric material to be drawn from the hatches in ships? They're
hatch.
large, yeah, not the hatch, but the hooks along with the cranes, where there is some electrical, some magnetic materials like semi-finished iron billets or something like that to pull it out of the hatch and drop it on the port. Is it like
No,
that?
no,
All
no,
those,
no, 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 no.
where
That
is
is
this kind of steel used? That is my question. With
that
high
I don't know.
silicon content.
That I need to see because in slides it is not provided. I have to check those things. And I will check in the 6 hours. This mostly okay. I will answer these questions. We are mostly, I think, going deeper and deeper. So this mostly for UG people. So I'm not that much prepared for that cases. We will see afterwards that how where it is actually used in silicon added steels. Okay. Okay. This question fine. It I think should work.
So, by saying the steel, what do we mean the about the mild steel or the stainless steel? If we just say steel,
Yeah, it depend upon the properties. We can say where it is broader question. It is not a bit narrow down question. It is just a still how much amount of, because it is varying from 0.5 to 5%. It is actually very large. The domain is. We are just concentrating that overall how much where the material how can be it be used. So exact we are not focusing on exact point. It is just a broader area. It is how up to this age it can be used, depend upon you where you want to use, because if you are asking very specific problems, so how where it can be used. So in case of specificity we have to go further, enhance, we have to go deep inside it. So right now for UG people that much deep I think is not required. We depend upon content that we are not supposed to go beyond the content, because more we are here to just give an overview this how the project is. We are bounded by the project actually. This slides. We are not going to say anything about this above slide that can be difficult. So we are mostly bounded by the slides. So our main guidance is slides only. So what is in the slides that we are here to discuss? Your any doubt about in the slides you have, we are here to discuss. So typical problems you can answer afterwards also. You can send me also, because right now our main domain is to UG. So if you go more specific problems, so I need to search also because my problem is different, my PhD is different. So that thing is to answer, but we have to find it afterwards. Right now the domain of the course is different, so it is mostly for UG.
Mr. Bharat, you will share this. material with us because
Ah,
I have
yes,
got
yes.
an. Okay, kindly just send me your email ID so
No,
that I
no,
can.
no, no,
I have
not
to
email
leave for
ID.
a meeting. Urgent meeting has come up, so
No,
kindly
no,
allow me to this thing. I
no, no.
excuse me.
That is not the case. Meeting is not there. It's shared in a drive. Everything, even this a YouTube video that is you're recording. This video is recording now. Everything has been
Okay,
recorded.
okay,
It will be down in, uploaded on a YouTube. The things
okay.
are shared in a drive also. So if you ask,
Thank you.
you can ask the specific questions in forums also. We can answer. But it needs to
Okay,
be
thank you.
for further study only. That is a problem.
Okay, allow me to
Hmm.
leave. Thank you.
Ah, okay. Okay. So okay, the sixth question. Yes, it's B because it reduces the weight mostly. So in fuel in aerospace mostly the weight is more important factor because it need to fly on the sky. So more less fuel will be so less weight, less fuel will be used. It's better. That's why mostly we are using aluminum alloys right now. So basically to reduce our weight. That's it. And mostly even the problems that here I design is based on the assignments that you have. So I'm not going any broad to the any deep area now. That is only the section. Facts I have to clarify. Again, this is the kind of theory part only. The major problem in the titanium what in molten state is. Yeah, it is chemically very active. Because I think you are slightly slow. You are searching or what? I'm not getting the things, but don't search. We can right now you can search, but this similar kind of problems will be coming in exam. So be ready to that much depth, so can you can score more. And also here we are mostly working to get that we should be more engaged with the such kind of small things, so you can learn more, grab more from the classes that are taught by the professors. So think in that case that what mentality the manufacturing engineer should have, so we can select the proper material in case of proper properties that we should have. About the limitations and advantages of each material is different, so to check what is what and where should we apply, where these kind of properties should be best fitted, and what are the limitations of this material. That to check that this material can be manufactured on the shop floors or manufacturing fields or not. That need to check. After only you can sign it as a correct, because you need to check everything. Most our in case of design, mostly professor also stated design it can be done by anything, that optimity can be reached anywhere. But in case of manufacturing, we have to show the final product. So for achieving that final product, we need to do many things. So for that, we need to take everything into the consideration. In design case, it's completely free. It can draw anything. It can be 100% also the ideal properties materials can be obtained. But in case of manufacturing, you are working with the real material, it's real everything. So in case of real, nothing is ideal. So there everything has limitations, advantages, practicality. Even most of the time, we don't have machine floors, machines on the shop floor. So that considers we need to consideration to take into account and just check everything properly. So this is chemically C, I think, the correct answer. So these again, turbine blades are made from super alloy. Yeah, it's correct. It's nickel. What about? Okay. Yeah, it's nickel. It depends upon the structure of the nickel, the atomic radius, and how it is fit into specific things. Depend upon how the microstructure changes. That microstructure, the properties will change. The strain hardening will be there. or gaps in that interatomic molecule, that atomic gaps will be changed, the slip planes might change. So depending upon that doping or the alloying element, the properties will change, and according to that property, we can see our application where it is applicable or not. So depending upon that, the we should use what is this. It is nickel is correct. Okay, this is the question. Right? What is not a form of ceramics? It's more simple. It's dendrite. Dendrite is nothing. It's actually your neurons. Oxides, carbides are completely different. Dendrite is completely different. It's biological term actually. So it's different. So yeah, mostly oxides, carbides, and nitrides, mostly ceramics. It are used in ceramics form. Dendrites is correct option. Mm. No, it is not correct option. You have to check ceramics not temperature resistant. Ceramics, silicon carbide, aluminum oxide, carbide, nitride, even silicon nitride. These are the things. It's I think, yeah, it's abrasive particles. Mostly it is using abrasive particles. Even I am using it as abrasive particles. Silicon carbide is at a hardest material because it is ceramics. It scratches the material. It goes due to the more hardness. Again, it does not contain. This kind of tricky questions might be there in exam, so you have to be prepared for that. So, what kind of questions might be there?
For the previous question, the more correct answer is abrasive particle.
Ah, yes, yes. Mostly it is
So,
using abrasive particles.
so if it is a multiple option, then we can select the temperature resistant also.
It is not resistant.
Ceramics won't be used as refractory material.
Refractory material can be used. It can be also, it can be used also, but mostly it is used as abrasive particles.
Okay, sir.
Mm. Yeah, it's correct. It's carbon. Mm. Carbon is correct. Yeah, it's correct. Substitution process composition. Yeah, it's correct. Yeah, it's correct for me.
So for finishing and milling, which will be the favorable? It should be brittle.
Finishing it is scratching metal most. Finishing, how would you scratching? This finishing is mostly grinding process. So in case of grinding, these things will not be applicable. Ductility is not at all close to it. And milling is again a different property, different case. It is machining problem, finishing a machining process. So there is ductility is completely different. In milling is mostly by cutting the material. So ductility is not part here. Mostly useful how much it can deform. What is forming? Your forming is you are deforming the material. Like in sheet metal, you are stretching it to get a form. You know the forming process actually. Like we are making the stainless steel glasses. It is a forming, curve forming and drawing process. In case of how much it can be drawn or how much it can be elongated, that is the most important property. So it is called as forming, the ductility actually. So how much it can be elongated, copper and this copper mostly aluminum, it can be elongated. So that is what we are using the ductility property, that how much it can be elongated, and that is where mostly forming comes under. In that cases only, the forming we are mostly it is elongating. We are making the according our die. We are according our shape that we want. We are forming it. So ductility is mostly for forming only. Other the injection molding, milling, and finishing processes are not close to the ductility property. So forming is only the correct answer. And in finishing, mostly we are scratching. So what is the hardness of the other material? It will take into consideration that what is the hardness, how it is impacting, how much material it can be removed. In case of milling, it is plainly the hardness mostly or the strength of the material. That how we can remove it in form of chips. In milling, we are doing in form of chips, and in injection molding, it is again polymers cases. So only in case of forming, the ductility can come into the picture. That's it. So
Yes.
yeah, it is hardness test actually. ISO is a hardness measurement test. No, not hardness. What is this? Uh, Toughness. It is actually measuring the, how much tough material it is. Impact test. ISO test. We are actually scratching the material. Like I think people are know that sir is actually asking how the it can be actually like this. There is a notch, and I think so. This impact testing how much what stress. It is actually the center actually, right? Not the center. It is actually half, and the rod is placed from this. To check how much fracture it can be before it is completely. It is ISO test actually. So such kind of test we are using for hardness, sorry, toughness measurement, not hardness. And these are like how we can measure hardness by scratching the material. So by different indenters that we have scratched the material and check what is the level of the scratching. So by different scales are there like rocker scale, Winker scale. Scales are there like A, B, C scales are there. So depending upon the scales, we can get know how much hardness it has actually. It
So
is
is this new test same as kind of the Rockwell test? Maybe international is made.
indentation is different. I think in case of Noop, it is completely square like it's very like rhombus like structure. In case of Rockwell, it is different. Venus, it is I think cone. It is we are using ball here. We are using a cone like structure here. You this type of rhombic structure we are using. It depends upon different indenters. Uh, different
So
indenters.
for new test we are using
What?
sheet like structure.
Where?
I didn't understand. For the Rockwell we are using cone for
Co-
indentation, and for new test what you said I didn't understand that about that.
For what?
New test.
Newtus.
Option D.
Noob test. This is the rhombic actually. Indenter is different. You know the diamond kind of thing. The indenter is different just. Like rhombus like indenter they are using.
Okay, so
It is indenter, there are different indenters they are using for noob test.
okay.
Mm. This is different by indenter, that how much indentation it has in the material that will be checked. So depending upon that material and that the specific geometry I think we are working. It depend upon geometry. Geometry of the indenters the test at vary. Mostly it is changed by indenters only. Yes. Yeah, it's correct. It's 0.02. No, this is not elastomers. How much question do we have? It is thermoplastic polymers. It is not elastomers. It is given in that tables for elongation. You can see it is only value with 100%. So you have to check that thermoplastic means when we are heating, it is getting plus. Yeah, it means like every plastic that we are using is thermoplastic only. When we heat, it gets soft. We can have a complete elongation. It is given the table also. The thermoplastic is having 100% elongation. So you need to see every properties it is given in that. There are many property tables also that ASME has. ASME and many data log tables are there available. You need to check through that research has already been done and in those areas. So how what is the amount of things that we can get? It is mentioned there. So to refer those kind of things. So how properties will change. You can get an idea about how the actually the research data that is that been there. It has been plot compiled in some ASM handbooks are there. So you can go through the handbooks and get how things will work. So but right now the I think in slides it is mentioned that thermoplastic polymer has 100% of elongation. And this is again question. Again we are going to the flow strain now because this is the more important case now. So how the material is flowing in case of plasticity we are need to check how the material is flowing. So it is specific condition is mentioned that is elastic and perfectly plastic category. So it is so its correct answer is zero. So how it is moving actually in case of that, this is just how it is moving. Here our n is equal to zero. So that is the condition that I have mentioned there. Here our n becomes zero. This is the zero is the correct answer here. Value of strain handling expert, perfectly plastic category. It is zero. You have to check these are important aspects in through gate also. You have to check those things. In gate also, these kind of problems might be asked to you. So these things also to keep in mind at what kind of problems might be asked in gate questions also, gate papers. Again, this is the kind of typical problems.
So,
Yes,
so in the stress strain graph, what's the reason for there is a drop after the yield point, isn't it?
this is
There,
what is the case? Elastic and perfectly plastic category of strength and relationship. You have to check everything. preferably mentioned here. What is the category? I think you need to refer the slides again. It is in second slide, third slide, I think so. It is a specific property in elastic and perfectly plastic category of strengths and relationship. It is specific category that I have mentioned. From that mentioned category, I am asking the question. That is the concept here.
Okay, sir.
Okay.
Okay, sir.
Yeah, 0.4 is correct answer. It is in there. So it can be approximated, not actual. But these kind of things you can do when you are production floors. You can partially get that what might be the value, so it can sustain the cases or not. So for quicker equations, and this kind of problem might be asked into it. Mostly, this kind of problems are asked. You have to keep these things in mind while giving for actual exam also, because this problem kind of problem solving this is very important. It can be approximated very fastly than actually going to the mechanics and solving how the things are actually working.
So that relation came from the formula, G and E formula, 1 plus mu.
That I don't know actually right now. I'll go through slides only. You have to see.
Okay.
You need to I think you need to check, because right now my focus is to get at what is the relation, how it is came. That is not right now my focus right now. So you need to check, you have to go deeper inside at how it is actually coming. Right now, I am like I can't go beyond the slides. If it is mentioned like this, so I have to go like this, because this is just an introductory section. There are many things that you will ask need to get afterwards. You need to go very deep at first itself. So if you go very deep at first itself, it become very hard afterwards. So right, slightly we are increasing the level. So now getting directly to the actual points. We are just introducing that what is the things, and for if you want to go more deep into go for specialized courses, for that it is again different case. Mostly this is the relation mostly you can use for quick approximation. It is only approximated value. Might be came from the relation that you are talking about. Might be some research data. It might be there. So it is just approximation. So it's approximation. If it's coming from any background, it might put as is equal to sign. So if it is not put, it might be some approximation just only. It just kind of rough sum that it can be equal to that. That's only the answer. More point to focus is at sufficiently high temperatures. This kind of question might be mostly against this kind of things you are mostly to work. And this question mostly asked will be asked not in exams but in gate like something. So these are the things we will mostly use. So again, what is the point here? Sufficiently high temperature. So at sufficiently high temperature, the strain which can be generated, it can be nullified that instant itself, because it is not getting strained, because the material is act like a soft right now, and recrystallization will be there. The stress-free strains will be generated again as it is get strained. So the correct answer will be zero. Zero is the correct answer, because we are setting a sufficiently high temperature. That is what we are working at. Sufficiently high temperature, the strain hardening coefficient. So at sufficiently high temperature, that's why we are using sufficiently high temperature. So get less force and our production can be maximum. So mostly it is recrystallization temperature above. It is called hot working. The work what we call as hot working mostly. The case that our hardening coefficient must be so hot working. It is called this kind of problem. So our hardening coefficient will be so with increasing our elongation, the hardness will not be changed. It will not be increased. It will be remain constant mostly. It will be slightly reducing because we are hitting a temperature. So most of the cases, the professor also told in the videos that we are hitting the temperature, we are hitting the material say, while chipping or while machining. What it will do? It will simply reduce your it will not allow them to strain. It makes material softer. It will be easier to cut. So our main focus is to shear the material. And when it becomes heated, it is easier to cut. So we are hitting mostly people are working as a researching, but not practically it, because again you have to put energy in it. That is against how much amount of energy you are putting inside the machine and how much amount of output you are getting. That you also should think. If it is not that much, then we should not go for that machine. That we can go with whatever we have. So that thing you need to consider always. That what can be put into manufacturing, should not be put. That we need to check. And it is efficient. Mostly optimal condition you need to check that what is the optimal process parameters or what is the optimal condition for it. You have to go for optimality every time. So for that optimality, you have to check everything. Again, when we are working with materials, it comes to testing. How the test will become. Again, this is the more typical question. It is not straightforward. It is kindly difficult question. Right, spending. Yes, because it is shown there, like this we are doing. The materials will be there, and we are bending, so it will be here. It will be compression. Here will be tension. So for hard materials, you can mention for hard materials what can be performed by which test. So it is bending test. If here we are using having a compression, and here we are having a tension. So here tension and here compression. So that's how we are using for hard materials mostly. It is given in the slides also. For hard materials only we are using this kind of things like bending test. No, like how the bending will be happen. This will be supports and we need to bend it. So this side will be in compression, this will be in tension. You can have how much compression it can be handled and how much tension it can be handled because it is hard, so it's better. So tensile strength and these things not that much useful, but so that's why you can do here. How it can be measured. Bending is correct answer. And it's the fluid. What is focused over here? It's a decreasing viscosity with increasing shear rate. That is the point. Decrease in viscosity with increasing shear rate. So we have to check. These are the standard problems. It is pseudoplastics. These are the standard things we need to stick. These are the standard definitions actually. So, so we have to stick with that definition. That is pseudoplastic actually. It exhibits decreasing viscosity with increasing shear rate. And check again how shear will be answered. Not it is not. We have to check the questions mostly where not is mentioned. You have to be very careful. It is not mentioned. Which is not. It can be also a multiple choice principle and I turned it around by using not. That's it. The fraction is completely different. Fracture again is completely different case. It is mostly for hard materials that how the crack is propagating inside anything. So it is a material how the crack is it is the kind of crack is generated over here by some energy. Correct crack will be generated here. So how it will be propagate. So it mostly come into fracture kinematics or fracture mechanics, how the fracture is going inside. Once mostly the cracks are generated due to some kind of oxidation or some defects that mostly present on a material that when it is generated at this point it will goes travel and it comes on the surface. Mostly vehicle come on surface. If it come on surface that means it's out. The material is out. You can't use that material. So it is material is gone. Then it is easily fractured. Yeah. It's kind of fracture means while making also there is fracture. After making there is a fracture in the material. So the cup and cone fracture. This kind of fracture will be happen. So this fracture is not stress in material, not subjected to such kind of stress. It is only shear, tensile, and compressive stress. And this is the fracture that you result. And the shears are actually the reason or cause how why it is hoving, and the fracture is actually the outcome. That is what is the result of it. So it is not a stress. It is actually a result of these stresses only, and only these stresses only then fracture will happen. There's some kind of tensile compressive. So this is will be a mostly your this is your output actually. This is your output, and these are your inputs. That these inputs are actually causing these things. So these are the different things you can specify. How can be differentiated? This is the output fracture, and these are the inputs. So these inputs the fracture can be possible. Fracture is there. Mostly this kind of fracture mostly happening due to these things only. This is the fracture is correct answer. Okay, so we are moving towards the problems now. This kind of problems only be available mostly there in your assignments also. This kind of problems are there. So I think for 1 hour, I think we should go with this only. You can. This is not that much, but these are the important things. Most of the things are covered by the professors. I gone through the video lectures also. So, but these are the things that we have because this mechanical is always about calculations. That what the thing that we suggest it is about calculations, how the things mostly about theory and practices it is, but it is about calculations. And mostly in case of gate also there will be a scales that answer should be in this scale only. In this specific range, that only case followed in NPTEL also. This answer will be in these only cases. These only a limit like 0.5, 0.5 to 0.6. So if your answer within that, it will be correct. If it is out, it is wrong. In case of gate also, it is exactly like that. Is between a range, specific range, it should be there. And then your NPTEL exam also, your assignments also, the exams are example like this only. What is the answer that we should take? It's simple. You have to focus on true strain. It is what is that? What is the true strain? You have to get a formula, and everything is very simple. This formula is very simple. It's not much. Let someone come with the answer. If it is not coming with the answer, then you want to check how much understanding do you have. Anyone can come with the answer if that we stop of time. Again, it is mentioned two strain. So focus on two strain. And again, elongated twice. These things you must take into considerations. These are the tricky things that we must take into consideration and how things are actually moving. You can type the answer in chat if you have. At 6, I will give the answer. But that was, we should give the answer. Like, what is the formula for two string? What is the formula that we may have? It's about ln, formula is also there, like ln by, so ln, that is your final, divided by L original. This is natural logic. It's ln. Just put in calculator, that's it. You have to check this twice and point it. Anybody to what answer? Uh, put in formula. That's only the case. What is your LF? What is your LO? Final and original. Sit. There is nothing. It will be then. It will be LN. What is our initial? This is 20, and my steel bar has been elongated twice. Oh, elongated twice. Okay, elongated twice means it elongated two times. 20 millimeter elongated two times. So it is what we had 20 plus two times elongated means 2 into zero point 0.8. What it will be? 1.6 divided by LO. That is my 20. That's it. You have to find the answer. Just put in calculator. 20 plus 1.6. That's it. Directly, if you put in calculator, answer will be there. Answer is 0.77. It is actually the answer is 77 something, 76 something, 0 point something 76, 0.076 something 9. So I will get to this answer directly. So this is just about calculations. Why we don't got answer? You just check that is elongated twice. Twice is important. It is actually there are assignments also check it to give proper. Yeah, it's correct. I have checked it, but I no one has answered. That's the question. So again, this is the answer. 0.0769 is the answer. So we can get to this only. This also 0.77. This answer we can. This is very easy. Actually, this first problem. Yeah, this is a relation. It is very easy. Just a relation that you need to check. So, it's straightforward. So do you get our previous answer? This answer do you get? Simple calculation. But why have not answered? What is problem in this thing? If you haven't, you can ask right now. It's very simple. This question, you have to solve a very big question afterwards. It's just a small question, very small. Okay, okay, we'll go. First. Yeah, if it go. So this is correct answer is directly. This is your engineering strain. Ln 1 plus C, this is your this is 2. This is your force. Mathematics is 2. Both are in is 2 strain actually. It's 2 strains. two strain and this is engineering strain. So it will be two will be linked with this. This two. Yeah. This relation is there almost. Again, this will be problem 26th. Solve these problems. Why you're not solving? I don't know. I think it will may take 5 minutes for you. Maybe can take if you want. Answer me at 5 7. Okay, read the problems. What do you have? And what answer should you get? To stress and also check the units. If the answer if different unit is given and to if, correct about the units. Most of the times the units can be changed. You have to mention the units. What unit you are asking, what unit you are giving the answers. Because it's about unit. You know, 50, the answer is 50. And 50 kilonewton is there's a thousand difference. You need to measure, give the proper unit. Newton, force, Pascal, viscosity. You need to be specific about answers also. And the answers will be given mostly. So, it is not mentioned over here. It's in megapascal. I'll give you the answer in megapascal. No, it's too it's answer in megapascal. Because in this previous case, it is just a strain, so it don't have any unit. So unit is not mentioned over here. Again, it's we have to through stress to give the answer to measure the unit properly. The unit must be given there. What are the problems that we have? We have uh, length. Here we have diameter. Length is just useless in here concept. It is uh, what is important again. You have length. You have diameter. You people are solving or not. That is one. You have to first find what is our question here. To stress. You know to write every equation that you have. Try to find the answer that is there any relation between this. What can you found? So it is length is given, diameter is given, tensile load is given, the elongation also is given. What you can find out. So as load is given, diameter is given, you can count out the engineering stress. So engineering stress can be found simply force by area. Force you have area, it is mentioned diameter. It's what you ask 0.2. It's not answer. Answer is 10 megapascal. Yet others also saw. So I told you what do you have? You have force. You have force over you. And area you have. Okay. Let's start solving. What do you have? You have length, diameter, force, and this elongation. So what you ask? Two stress in this case. You must what? How you can find two stress? Yeah, 10.10 is correct. But which I just it is actually 10.09 something 096. So it's correct. It is in the range, so I give 10 megapascal. So about any, it should be in the range. Specific range will be given to that range. This 10 point is actually correct answer. 10.10. So just for given, I get 10. So again, so there are two people more there. So how it can be solved? So I have to solve for YouTube also. So this is 40. So you got 40 millimeter, 8 millimeter diameter invisible to tensile load and 500. So what you have engineering stress, you can calculate. Your engineering stress will be 5 simply for F by A. What is F by? Simply your 500 divided by 5 by 4. It is area of cross section into D square. Or here it. So it's simply 500 divided by 5 by 4 into 5 by 4 to 8 square. So it came, quote it. So it will be, it should came translation of. So it's 9.9. Yeah, it's just ordinary. Is equal to 9.94. So that you got. That is done. You know the relationship also. You have to equate everything. Most of the times in GATE, such kind of problems usually given you to apply everything. Every knowledge that you have, you must apply. So if you start writing with the formula that you have and how you can reach to the solution that you need to check. But you are most wanted to reach the solution. That's it. Mostly you got six engineering stress now, 9.94, and after that you have elongation is given here, zero point 0.6, and it's 8 actually. Elongation is given, that is zero point 0.6. So what will be your strain? The engineering strain. So engineering strain will be equal to this given, this is zero point 0.6, so which is mostly yellow by it is your original final minus original divided by original. So it's 0.6 by 40. So again it will be 0.05 something and 0.15. And again you know the relation from it, that is 6. Your engineering stress will which is equal to your so this 2 strain is equal to engineering stress plus 1 into your engineering strain. So this is your engineering strain that you have 0.015. 0.015 you have, and this is your strain. So just put add and multiply. That's it. This will be 9.94 into 1.015. This will be 10.10 something that will be given. That's how we can solve this. You have to apply everything that you have with your user. This is a 10 point some, you know, 10.10 something answer with the megapascal. You also mention units. Units. And this is again another problem, which is transfer rupture strength. We must know the formula for this. But it is bending output of bending test. It is from the bending test actually. The length is given, just write what you have. Like you have length, you have breadth, you have thickness, you have load, and you need to find PRS. KMA is not mentioned in megapascal. It's about how it is output of bending test. The bending test is mostly your processing area will be there, which is resisting it, resisting the bending. It is about formula, so which can be resisted by your cross section area. So you have to take care of the cross section area also. How the bending will happen. Yeah, it's correct. 144. 144 is correct answer. Yeah. You have you suppose this formula putting, you must know the formula, that's it. Which is transfer rupture strength, TRS. You have to find out what is TRS. It's 1.5. It is there in the slides. We are mostly stick to the slides only. We are not going any other slides. What are content at I'm showing you through slides only. Because that is a main guideline for us. After that, we are just here to clear the out and solve problems. So you can get better in assignments and better grade score in your exams. It will be there. So the picking clear about our exam. So it is BT square. So it's 1.5. Force you have 800. Then length you have which is 60. Then you have thickness which is 5. And force it is given 800 Newton. So simply just put here everything. 1.5 into F. What is F is 800. So into 800 is L 60 divided by 20 into 2 raised to 5 raised to 2. 5 raised to 2, 5 square it is, so it is 144. The simple calculation. Put in this formula, this answer. In this, it is kindly that much tricky but slightly tricky question. This kind of question we have to complete exams. Here this is, yeah, the correct answer. Here it is given there also. You have to solve it. is given there. So it's about it is mentioned here. Yeah, I have extra spaces. So length L elongated twice to its original length. Means what is our initial length? That is our initial length will be L and our final length will be 2L. And from the it is written that elongated to its original to its twice length. It will be 2L. Just apply a formula that what you have to apply your engineering strain. True strain and engineering strain. What is true strain over here? Just apply a formula for true strain is equal to L and to L, that is final length. Final length divided by now final length will be divided by your original length. Your initial length is equal to ln 2 by 1. So it's simply 0.6 93 into percentage. It will be 69.31. Let's multiply with 100 because you're asked here for percentage in percentage. So to answer in percentage, so this will be to multiply by 100. Again, in case of your engineering strength, your engineering strength will be its engineering strength. Will be your engineering strength. That is L final minus LO, L original by divided by LO. So it will be L, 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 will be L. So it will be 2L minus L. L by L, so it is equal to 100%. Yeah, it's 1. So that would be 1 into 100 will be 100% would be your answer. The next question. So it's slightly tricky now. Okay, but we have to check what the question has been asked and how to answer the question. So again, very simple. You have to check what you have to ask. What is asked to determine the engineering stress at maximum load. That's it. Engineering stress problem for logging you already have. What is the formula to find engineering stress? And the at maximum load is the asked for you. You need to find engineering. Again, you need to focus on engineering stress. Not true. And the answer mostly be in range only. If it will go out of range, it will be mark zero. You need to check those things. It is everything will be mentioned. It again, it's very simple. It's just about anybody ask in chat. We not the it's very simple. It's engineering stress with force divided by the original cross-section area. So what is your maximum load it is applied? I'm asking engineering stress again. Yeah, it's correct. 109.7. It's 19 actually might be some different case. That this is what it is all about. This maximum force they have given is 44, 55. You don't Newton, so just put 55 kilonewton out there. So 55 to 10 raised to 3, it will be the into original cross-section area. It is 5 by 4 into t diameter square is the O square. So it's most just put the answer 10. So in my case it came 919. You can have one. It will be again in a range. So the next. It's similar like we saw it is previously. So answer it. To stress again we are asking. It is just previously solved question, but different. You have to check engineering and true. Where to apply true, how to apply true, and how to apply original. But not original engineering. And how it is differ. You have to apply correctly what it should be. Formulas are the same that we have previously. That's it. It's okay. Remember fast. 1344 is not correct. 344 is not correct. You check the true and engineering might be problem two in engineering because two and engineering is problem. You have to check what is true, what is engineering, where to apply true, where to apply engineering. Correct answer is 107 megapascal. Check here how it is 38. So two stress. That is important. Consider two stress and engineering stress. There is a difference. What to apply, where to apply, how to apply. Be very careful with the formulas. We have to apply engineering, we have to apply true. is not directly calculated by just fracture formula. To go to original root is mentioned like that only. Like previously said, I told you by using engineering stress concept. We find engineering stress first, then engineering strain at this fracture point. So it will be 38 kilonewton by 8. Or it is original, must be original, not 6. Should not be 6. So it is forming that only. So to solve the previous that is can solve, but in that concept it is not solved by this concept. Both are correct mostly, but answer is not matching. The 1.3 also will be correct because it comes from direct answer, right? Directly using 38 by 6. This is actual definition by definition. But by that book, I think it is gone to different value. You don't want to step. But in that case, they are going to different way. So in that case, they do engineering stress, and again, uh, sigma E, so engineering strain. From they are using the from that relation that is 6 into engineering stress into 1 plus E. From that, they are actually calculating the true stress in this fracture point. But it can be good one directly also. 1.3, 1.3 will be so correct answer. So both answers will be taken. Depend upon mostly I also think both are correct. But second one is more correct. 1, 3, 4, 3 will be more correct because it is solved by different approach. By taking the engineering because true it is not that much can't get the true value. So we are using the based on engineering we are using that approach. Mostly we should use this approach only. Engineering approach. True strain approach is not preferred. In context, this can be right, but I have to mention something extra here. So, okay, that's it. If we check what in the next session, I will say what would be correct purpose to this. So that is my different. What is they are mentioning at fracture point, so this approach should not be correct. This is only the way. But in real life, this is not used because we can't measure in the original cases. So in this case, is this answer correct from the problem? But in the reality, this approach should be used. But this approach is not done because who will fracture at 6 a.m. At fracture, there is we can't measure mostly at when the fracturing tensile stresses. This is not just a theoretical problem. Mostly in this context, this answer is right. But in real life, this is not the approach that we should use. So we should go with this engineering approach with original length. We have force, we have original volume, original area, and you can measure the original strength because after that you can measure. diameter and the length you can measure. But at exact at fracture, you don't know what is happened. So both the answers will be correct. Exactly fracture you don't know. In real life, this condition never happen. So in that case, both the answers are correct. So it's the case. So you also work on mostly in problem will be given, but you must know both the approaches that how you can use when to use what. In case of straight true, it is original. True means the actual happening, instantaneous. That is actually takes place. Yes. And in case of engineering, it is original only. Instantaneous, that is rapidly changing, instantly changing. In case of engineering, we should mostly go with original. And original, we mostly know forces we can handle, forces that we know what amount we applied. But it's fracture, we mostly don't know. At what at what means at what load fracture happened that we know. And after elongation, we mostly don't go with diameter also. We go with length. So we know the length, like previous problem, we know the length. In this context, both the problems are very I know, but because it is the data is mentioned that like that only, both the problems are correct. But in the real application, we can't measure diameter. Mostly we go with lengths. So in case length are measured, we have to go with this approach. And 107 will be correct answer there. This answer will be correct. We go by this approach. And right now, from the how the problem is framed, the 133 will be the correct answer. This is the last problem that I have. Again, very simple about compression. It's again a simple problem. It's not that tough, but mostly cover everything from compression, tension. These are the important things that we have covered. Next things we will cover in next lecture. Continue to solve. These are the because we have 5 slides for 2 weeks. So for 3 slides, I'm introducing right now. To the first 3 slides. After 3 to 5, I think so. We go for next Saturday. Mostly your assignment, if you see the assignments, it's like that only. Remaining days with the problems which you require to solve this assignment, so it will be covered there. And problems that we require for next assignment will be covered afterwards. Sufficiently progressively we go with assignments. The problems we need to solve. Again, our exams also sometimes what uh, things they have to show. Past. Hmm. This will be my first week because your assignments also structured in that way only. And this will be for second week. 3 and 3 to 3. No, not 3, 4. 4 to 5 slides for second week. Your assignments are only like that way. You have to submit by Wednesday, I think so. So it is you have 10 problems. You also got the assignment right now. 10 problems you have to solve before, and I think so after Wednesday you will get the answer on Wednesday. After Saturday I will solve it. So it's like that only. So this is what problems that we have. So we have to solve the previous problem. Okay. So mostly problem I covered. What is quite important. Some tricky problems also like this. What to take. Mostly in reality only you go with this. For context of this problem, you can go with this subject. In reality, you don't have to use this approach. In books also, this approach is preferred. In the book that I use preferred, is also this approach is preferred, but this answer is also correct. So this is the B answer you have also given. So again, it's simple. It's not that much like problematic. What it will be. So they have mentioned that the cylinder with L. So L original length will be it is my LO or original length or initial length is L. And after that, the final length will be it is LF. It is L by 2. So we know in how to find engineering stress. The engineering stress. What to find it? What the strain? Can find stress? No, stress is not given. Have to find a force. Consider 800. Now time, yeah. If you can solve for 800 also, you can use as a F. And the area also not, you don't know. And initial diameter. And then here also. Use F. We exactly use these conditions, but use F as a force and L or that is not L. Yeah, L as zero point 0.5 and find the two stress. That is your stress you need to find out. Like question 31 to 32 we can have because it kindly problematic that previous question, but like in 32 we can solve. So if you what you have here it's very simple. Is L by 2 minus L by L, which is again equal to zero point 0.5, and your two strain will be equal to ln L by divided by L. Okay, it will be ln zero point 0.5. This again is minus because it is L by 2 minus, so it's minus 0.5. And it is a compression, so its minus sign will be there as always. Because it is a compression, and both of the cases from negative side you can get it is compression. So if it is positive, it will be tension, and it is compression, so negative side must be there. Okay, so we form problem 32 here. Use FS 800. Go. This is exactly same everything. Just use force as 800 Newton. Your length will be 0.5. Oh no, take 5 millimeter. That is your initial length. And find the true stress. So in this case also, just need to add one slide. Just like formula 20. What we have here F is equal to 800 Newton. That's type also. We have F is equal to 800 Newton for original length equal to 5 millimeter. Just use the same formula to find true stress. I will solve that now. The same previous approach. Like you know F right now, so you can find engineering stress. Diameter of a tube. Diameter is not mentioned earlier. Diameter maybe 6 millimeter. We can take original diameter. So you can factor, you can find from the composition ratio. You also find so we can find F over here with my principle. Uh, you know, exact same concept you should use like engineering stress should find out from the this force you have, original diameter you have, so will be F by pi by 4 d square, and you can find engineering strain also. Hello by hello by hello minus LF minus LO divided by LO. This is E, and you can after that you can find your engineering stress. Heat stress that is C, sigma E 1 plus E test. Okay, so we have to find the answer in megapascal again. So we just calculate the answer. Will be 800 by pi by 4 into t square will be 6 millimeter, the original length. So and you know what will be the final length. Final length will be equal to 10 millimeter. No, it's 2.5. Because we are going to be compression now. We just extended the problem. We have time right now, 52, so we can extend slightly 6 to 52. So we have engineering state which is equal to 800 divided by 5 by 4 into d square. So it's going to be 800 into 5, 5 into d square will be original diameter is 6. is equal to 7.0735. Need to find the engineering strain now. Engineering strain need to find out. So how we can find the engineering strain? Is again final by LO by LO. Finally, half. So it's 2.5 minus 5 divided by original is 5. So mass will be negative. So 2 minus 5.5 divided by 5. 2.5 5 by 5 will be 0.12. And we must know the curve also. It is increasing in case of compression. So we need to also need the curve minus 1 by 2. So you know what is the stress, you know what is the strain. Mostly it is equal in both the compression and the compression must be. You know engineering stress, in which you must know the true stress is equal to true stress which is equal to your C. Just 1 plus E is 1 plus E will be so. So as how your stress will be reducing is again an important question that why it is reducing because the area is increasing. I think no one is left, but the area is increasing. This is again an important question because area is increasing over here. So stress is going down because we are going minus right now. See, we have 7.0735, but uh, you know this in megapascal area. One right now your engineering stress is one minus. Minus 2 because it's yeah it's half it's 0.5 minimum is half that is power half. So it will be 7.0735 into 2 into half because it's half going. So it will be reduced to 3.5 only. Why? Because we are going compression region now. What actually happening over here? Uh, you must remember what actually happening here, what we are doing and what happening. What is the final answer for true stress over in this case? Should be 3.536. 3.536. This must be your point right now. To be answer megapascal. Why it is going down? Because yeah, it's 3 multiple to stress to find the two stress, isn't it? Find two stress. So it's sigma. So it is so it will be sigma. Just a sigma. It's two stress. You have to find two stress. And two stress answer we got, which is a sigma actually. Sigma E, you know engineering stress. We also can find that the two strain will be ln. It will be ln divided by L F by L O. So we will again we just find out here ln of 0.5, 0.963. So this is the what answer we got B. And here we find out what is true stress, sigma in megapascal. With the sigma for this condition. That is, so here you will answer will be 3.56. So just write here what is the answer. 3.536765 megapascal. So solve this kind of problems also. I think I have taken every kind of problem with you right now. What is solved, what is important. Other rest of the things are quite simple. So from the first week, I can say that this will be enough. After that, we can see after classes, we can see the next session, the next things. So yeah, here we are. Yeah. After that, we can find different sessions after this area. So this will be your final answer. So by doing everything, what you got is this answer. What main focus is your that you should get learn. That's why we have to create problem to solve problem. So it is one of one piece of competition. Okay, so it's even and in a problem you state that it is getting doubled. It is now 2.5 after LM. So if you have to consider it's LF and LY. Yes, that's it. So thanks for joining today. We are back closing our session.